In the last session, what we were talking is we were talking about the model foundation. So we have completed how to draw the grid lines or how to model the grid lines. And then we have defined the material properties, that is concrete, and also the steel properties we have defined. And then we have two different types of columns. So we have defined those column properties also. So now we are going to look for the slab properties. So slab is nothing but whatever the foundation that we are going to design. So for that foundation, we will have a slab. Suppose if you take a simple column like this. So column will be resting on the footing. So this one is called as a foundation slab. So whatever this portion that you are going to see, this is called as foundation slab. So now, if you remember in the last session, I was showing you a couple of details regarding the foundations. So let me just show you that. So here we have two different types of footings. So one is footing one, which is having a dimension of length 3000 mm and width 3000, width 2000 and depth 500. And similarly, the footing two, 3000 is the length, 3000 is the width, and overall depth of the footing is 400 mm. So now we have to define these properties. Okay, these two footing properties we have to define. So these two footings, I'm calling it as slab properties. So technically they are slabs only. So let us define the slab properties of both these footings. So in order to define the slab properties of the footings, we have an option which is called as a define. In the define, when we are defining the material properties, we went to materials. Now we need to define the slab properties. So just below that, we have the option called slab properties. So just click on the slab properties, a dialog box will appear, and you can see there is a default slab that is available. If you want, you can edit the existing slab, or if you want, you can create the new property also. Let me show you both the options. So first, let me show you how to add a new property. So just click on add new property, and here we should give the property name. So the property name can be anything. Let's say I'll give it as footing one, okay, which is having a overall depth of 500 mm. Okay, 500 mm is the depth of the footing. Let me cross check that. Yeah, for footing one, the overall depth is 500 mm. So the grade of concrete is M20. So that is what I'm going to give. So just for my identification, I'm giving it this way. So footing one, 500 mm is the overall depth because we have two footings with two different depths. So I'm giving it like in this way. And the grade of concrete is M20 and the slab material. So usually we are working with the M20 grade of concrete. So I'm giving it as slab material as M20, and then display color, let it be like this, no problem. And then type. So what we are designing here. So usually here we are defining the slab. So technically it's a footing slab or foundation slab. So just click on this drop down and you can see an option at the bottom that's called as footing. Okay, that's called as footing. So select this option. So here we can also select the slab as well. There won't be any problem. So either you can select the slab or you can also select the footing. In either ways, there won't be any problem. But don't try to select this drop stiff because these two things will come under, drop will come in flat slabs. Stiff portions will be coming, we'll be talking about stiff portions in some time. Waffle slabs, ribbed slabs, again, these are two different roof slabs. Matte foundation, we'll see once we design that. So here, as far as the slab is concerned, either you can take the slab or footing. That's completely up to you. So since we are working with the footing only, even if you take the slab also, there won't be any problem. That's for sure. And then the thickness it is asking for. So in our case, the footing one is having a thickness of 500 mm. So I'll just give it as 500 mm as the thickness of the footing. And then you can check the thick plate. It's again up to you whether it is a thick plate or a thinner plate. So usually whatever if you remember the concept of finite element methods, all the sections, whatever we design, we consider them or we assume them as thick plates only. So shells and plates and shells concept. So we consider them as thick plates only. So let it be the thick plate condition only. And then orthotropic, it is just a view. So I'll show that view by clicking on 3D also. In either ways, it comes, no problem. So you can leave this option unchecked, that is orthotropic, and thick plate, let it be checked only. So, and then click OK. So that the first slab, that is F1 underscore 500 underscore M20, the first footing slab we have designed. So now let us do the second one. So we have the second footing, which is having an overall depth of 400 mm. Now what I'll do is, instead of adding a new property, let me show you the second option that I have. So instead of deleting this, what I'll do is I will edit this one. So how to edit this one? Just click on that one, just select that one, slab one, and then you can see an option called modify or show property. So just click on modify or show property so that you can modify the existing one. So the second one is footing 2, which is having the overall depth of 400 mm and the grade of concrete is M20. Slab material, again, M20 is the material of the slab, and the type, either you can take slab or footing, anything is fine. So I'll go with the footing, and the overall depth or thickness of the footing is 400 mm. So let the thick plate be checked and orthotropic, let it be, leave it. I mean, let it be unchecked, and then click OK. So you can see both the types of footings that we have modified. I mean, we have given the slab properties. So this is how we can modify the existing slab property, not just the slab, even the beams, columns, whatever that we want. So that's how we can define the slab properties. And then, so we have only 2 slab properties. So I defined only 2. So you have to define all the 5 slab properties. So let me click OK. So with this, we have defined the slab properties. So technically speaking, we have completed defining the column property. We have completed defining the property of the slab. Now what we are going to do is we are going to do the modeling over grid lines. Okay, that's our next task. So we need to do the modeling of grid lines. As of now, whatever the material properties that are there, we have defined all the material properties. So the next thing that we are going to do is modeling of our element. Okay, the modeling of our element in these grid lines. So we have to model the footings, right? We have to model the columns, orientation of the columns, all these things. So let us do that. So for that, what we have to do is, first let me show you the CAD I mean the drawing part here. So here you can see there are slabs, I mean the foundations, that is footing 1 and footing 2, two types, and there are columns in each of the footing. So like this, we have to model all these columns, including the orientation. So orientation we should not miss out. So orientation is very much important, right? So if you want to draw, now what we have to do, I want to draw, see, this is a grid point. So this intersection points are grid points. Now what I want to draw an area around this particular point. Okay, if you want to draw an area about any particular point, we have an option. We have talked about that one in the very first day of our ETAP, I mean, SAFE software. Let me show you that. So for that, what we have to do is, suppose, let's say, I want to model a slab somewhere, let's say at this particular point, I want to model. This is my first point, right? So this is grid point A1. So if you keep the cursor there, you will understand grid point A1. Now what I want to do, I want to model the slab here. Okay, I want to model the slab here. So how to do that? So in order to do that, around a particular point, I want to model a slab. Like this, I want to model. Okay, around a particular point, I want to model the slab. So how to do that? So for that, what we are going to do is we have an option which is called as quick draw areas. You can see here, quick draw areas around points. So just click on this point, that is quick draw areas around point. Okay, click on this one. So a dialog box appears, and here we have to select the properties. So the type of object, it is basically a slab. Shape, let it be the rectangle shape. Okay, and then property. So how many properties we have? Technically speaking, we have 2 types of footings. So you can click on this drop down, you can select either footing 1 or footing 2. So how to select that? So in order to define which exact one we have to select, we have to go to the CAD drawing and we have to identify. So you can see the first one is a A1. So A1 grid point consists of footing 1. Okay, A1 grid point consists of footing 1. So like this, we have to select each and every grid point, and then we have to model the slabs. So let me do that. So A1 grid point is having footing 1. Okay, footing 1. So let me go to the save, and then let it be the footing 1. Okay, because at this point we have footing 1 only, and then the X dimension. Okay, so what is the dimension of the footing one? What is the length and width? So here, if you go to the CAD drawing again, we have the length and width criteria of footing one. So what is the length and width? So for footing one, the length is 3000 mm and width is 2000 mm. Okay, length is 3000 and width is 2000 mm. So let me define the sections here. I mean the member properties here. So X dimension is 3 meters because here the value should be given in terms of meters. You can see the dimensions also. And the Y dimension is 2 meters. I think it is in reverse. Let me check. Yeah. So here it is 2 meters and here it is 3 meters, right? So X dimension is 2 meters and Y dimension is 3 meters. And let the trim at edges, slab edges be yes, because we need a proper rectangular lines, like we need a right angle triangle. So we need exactly like this. So this portion we need. So if you don't select S, suppose let's say here you have selected no, how it comes is, it will be like a curvy portion. So this curve you will get. So we don't design any kind of materials with the curvy section. So we always design in the exactly right angle section. So that's why trim at slab edges should always be yes. Whatever type of design that you are designing, it should always be yes. It should never be no. Until or unless if you are designing a something like a curvy members. Right. So let this property be yes. And then now what we have to do is, now we need to go to the footing one. Okay, we need to go to the footing one. That is at this point, grid point A1. Now what you have to do is move the cursor to grid point A1 and you have to see that red color plus symbol. Let me show you that. Right. So when you see the red color plus symbol, it indicates you are at the midpoint. Okay, you are at the intersection point. Once you see that red symbol, click on it. Okay, so you can see a slab has been modeled. So this is the slab. So you can see the slab has been modeled here. Like this, we have to model at each and every grid point. So that's how you can do the modeling part. So this is how we can draw the footing here. Okay, this is how we can draw the footing. So like this, we will draw the footings for all the sections. So first, let me go with the footings, all the categories which is having F1 category. So let me check that. So wherever F1 is there, I'll just click there so that I'll get directly all the points. So let me come from the bottom. So footing one, here A1 it is there, and then here it is there. Okay, the last one. So let me click here as well, grid point D1, and then next points are, if you go to the top, then B2 we have, and then B2, are there anything else? Um, yeah, so B2 and B3. Okay, B2, B3 we have both. So let me click on B2 and B3 as well. Okay, and then let me zoom out a little. Yeah, so in the second column, so we have B2 and C3, C2. Okay, B2 and C2. And then in the next line, that is in the third line, we have no footings with F1 category. In the fourth grid line also, we have no footings with the F1 category. So let me go to the fifth one. So in the fifth grid line, we have the center two. So let me go to the fifth grid line, the center two. So grid point B5 and grid point C5. So that's with respect to fifth grid point, fifth grid line. And in the sixth grid line, we have the first one and the last one. Okay, the first and last one are F1 categories. So let me go here, click on the first one, and then click on the last one. So like this, we have modeled we can model the slabs. Okay, these are actually the F1 category types. Now all the remaining categories are F2 categories only. So you can close this dialog box and then you can go, you can repeat the same thing, or you can directly select F2 here. Okay, you can directly select F2 here and click on all the remaining points. Okay, wherever remaining points are there, all the remaining points are F2 categories only. So let me do that. So before that, let me close it just since we are at the beginning stage. So click here and then next category is footing 2. So I have selected footing 2 and let's see what are the dimensions of footing 2. So if you go to the top, the dimension of footing 2 is 3000 and 3000. So length is also 3000, width is also 3000. So let me give 3 along X and 3 along Y. Right. So trim at slab edges, let it be S. Now let us click on all the remaining points. Whatever the remaining points that are there, just click on them. So you can see a square footing is being modeled. So just click on them. That's it. So let me click on all these points. Right. So that's how we can model the slabs. So once you complete your modeling part, you can see, so all the slabs have been modeled. Once you complete the modeling parts, close this dialog box and then remember the command is still in the active state. So how to disable the command? You have to click on the select object at the left pane. In the left pane, the top one that you see, select object. So click on that so that the command will get disabled. Right. So like this, we can model the footing slabs. Now, if you want to see the same thing in 3D view, so how to see that? So just click on 3D and you can see all the slabs has been modeled. Okay, the slabs has been modeled. But here, this is how you can model the slabs. So here, if you see, there are two layers that you are seeing. So if you click on this rotation symbol, okay, at the top in the main quick access bar, so you can see the rotation part, right? So you can see all the slabs has been modeled and these are in the 3D view also, right? So now the next thing that we are going to do is we have to model the columns. Now we have modeled the footings, right? So let us model the columns now. So inside each footing, we have to model the column. So let us model the columns, right? Just give me a second, right? So let me go to XY plane, right? So let me disable this one, right? So now we have to model the slabs. I mean, we have to model the columns inside each footing. So let us see that also. So in order to model the columns, so for F1 type of footings, if you see this one, so for F1 type of footings, we have which column? Column 1. Okay, for all F2 type of footings, we have column 2. And column 1 is having a width of 230 mm and overall depth of 600 mm. Okay, and column 2 is having a width of 450 mm and the overall depth is also 450 mm. So technically speaking, this is a square column. Column 2 is a square column and column 1 is a rectangular column. Right. So now how to model the columns here? So in order to model the columns, just go to Save Software and here you can see in the left pane, there is one option here, this one. Okay, there is this option here. What does this option indicate? It indicates a draw columns. Want to draw columns, just you can see, I'll keep the cursor there. You can see draw columns option is being popped out. So now whenever you want to draw the columns, you have to use this particular option. In the left pane, I guess you are able to see. So just click on this one. Okay, click on this one and a dialog box pops out. You can see, right? And forget about this dialog box for some time. Now, if I take the cursor outside, can you see a small rectangular box that is following the arrow? Right. So this is our column. Now we have to model these columns in each of the footings. Now, before modeling the columns, we should know what is the orientation of the columns. Okay, whether the columns are oriented in this way. Okay, this is one type of orientation if it's a rectangular. This is another type of orientation if it is a rectangular. And if it is square, there is no problem. Okay, these are the three types of orientations of columns, be it square and rectangular columns. Now we have to be very careful which footing is having which type of orientation of column. That is very critical. Okay, so right. So let us understand that one. So how to get that one? In order to get that one, we have to look into the drawing. So let me go to the footing one. I mean the very first footing. So you can see here the very first footing. So it is having which orientation? If you observe, it is oriented in this way. It is oriented like this. Whereas this one, it's a square. So there is no problem with this. And again, the next one. Okay, this is also a square. But with this one, it is purely again, a rectangle like this. So you have to check these drawing and then you have to model the things accordingly. Okay, we have to model these things accordingly. So let us do that. So the first one is having in the rectangular orientation along the y-axis. Okay, it is oriented along the y-axis or the longer axis, you can say. Right. So now here, one thing that we have to remember is, let me go to the Save Software, and here you can see the type of object. It is basically column. So property, below property. So here you can see there are two properties, CM 230 by 600, CM 450 by 450. So here there is another option which is called as none. So this option means whether we want to model the column below the footing slab or above the footing slab. Okay, this option none indicates. So property below means whether you want to model the slab below the footing. And then you can see the next option, which is property above, whether you want to model the columns above the footing slab. So logically speaking, we always model the columns inside the footing slab. okay, inside the footing slab. That means it will go deeper into the section. Okay, understand this option. So this option, none option, means whether we want to model the column below the footing slab or above the footing slab. So usually for normal columns, the columns are modeled above the footing slabs. Okay, the columns are modeled above the foundation slab or footing slab. But whereas when you design the pile foundation, we will model below the foundation slab. Okay, for normal footings, we will model above the foundation slab. Okay, this one. So for normal foundations, we will model above the foundation slab. And for pile foundations, we will model below the foundation slab. Why for pile foundations? Because if you consider this as the ground layer, okay, if you consider this as the ground layer, pile foundations will go deeper into the ground surface. Okay, deeper into the ground surface. And then here we will get the pile cap. Okay, we'll get the pile cap. And above the pile cap, we have the surface of the road, whichever the embankment that you see, that is all above the pile cap. So we will not focus on the pile cap design, but let us focus on this one to avoid confusion. Right. So property below. So property below should be none. Why? Because all the regular type of footings, except the pile foundations, so all those footings or all those columns, we will model above the foundation slab only. So property above, the next one. So property above means we have to select the column. So which column? So let me go with the first column, 230 by 600. So CM 230 by 600. And height below. So height below, how much height it should be there below the ground surface? There should be no height. So it should be 0. So below the ground surface, we don't have any columns. Or columns will be there above the ground surface only. So that's why I'm giving height below is 0. If you give height below 0, what will happen is, if you give height below, let's say I'll give it as 1. Now what will happen if this is the ground surface? Column will not have like this. Column will not be constructed above the ground surface. Column will be modeled below the ground surface. That is what height below, height above indicates. So we don't want to model the columns below the ground surface. So which columns we model below the ground surface? Only pile foundations. So when you are designing pile foundations, we should give height below. But when you are designing the normal columns, we always should consider height above only. Okay, we always should consider height above. So let me erase this one. And what is the value that you have to give here? Height above. So for that, if you refer to the CAD drawing, so usually the column height will be given as 2.7 to 2.9 meters. Let me check whether that value is there or not. Yeah. So here you can see the depth of the foundation. Okay, the depth of the foundation, it is given as 2.9 meters. This one. 2.9 meters. So this is the value that you have to give. So height above is 2.9 meters. So let me give the height value, that is 2.9 meters. Height above. Okay, height above is 2.9 meters. And then plan offset X and plan offset Y. So we don't need any offsets. We need exactly at the center point. Wherever we'll click, we need exactly there. And now the next thing is the angle, which is very important. This is the point which actually decides the orientation of the column, whether you want to orient in this way or whether you want to orient in this way. So if you want to define these orientation, this angle is very crucial. So let us understand this one. So how to do that? So when you give 0, what does it indicate is you can see 0 means it is coming along the x-axis. Can you follow the cursor? So it is for coming along the x-axis. So here for footing 1, what type of orientation it is there? Again, let us go back. So here you can see the orientation is there along the y-axis. Okay, the orientation is there along the y-axis. So how does it indicate? It means the orientation is like this. Okay, so let us orient in this way for footing 1. Right. So here, how to make that one? So if you give, suppose let's say, if you want to orient in this way, okay, if you want to orient in this way, the angle value should be given as 90 degrees. Okay, if you want to orient along the y-axis, the angle should be 90 degrees. If you want to orient along x-axis, okay, if you want to orient along x-axis, then the angle should be 0. Now, let's say you have, in some drawings, we have typical orientations, something like this with some angle. Now, this will have 135 degrees angle. or 45 degrees angle based upon the rotation factor, right? So that's how you can orient the columns, right? Since we don't focus on this one, let us not bother about this one. Now we need to bother about only this one because the first footing is having an orientation like this. Okay, right. So let us give the angle as 90 degrees. Okay, let us give the angle as 90 degrees. And once when you give angle as 90 degrees, you can see you follow the cursor, you can see the shape has got changed. When you give 0, what will happen? Let me give. Right. Can you see? The shape is horizontal. When you give 90 degrees, the shape is vertical. Suppose let's say I'll give it as 135 degrees. When I give 135 degrees, can you see the orientation? How it got oriented? When you give 45 degrees, see, so that's how you can orient the columns in the modeling part, right? So currently we will go with the 90 degrees modeling part. Okay, let me click here and then cardinal point. So what is this cardinal point? Cardinal point is nothing but here you can see C tooltip. That is again, we'll not bother about that one, but let me tell you what is this cardinal point. Cardinal point is nothing but whenever you are modeling the columns. Okay, whenever we are modeling the columns, we always have to remember cardinal point should always be 10. Why? Because whenever we are going to model, so forget about all these ones. We'll talk one by one about these ones. So whenever we are modeling the columns in a typical construction, we always work with the centroid point. Why we need to work with the centroid point? When we are defining or when we are discussing the manual design, I always used to tell that the load which is coming from the column should always coincide with the foundation slab. Only when these 2 points get coordinated or only when these 2 points gets meet at one point, then only we will have uniform settlement. So when the centroid will not get coincide, the center of gravity of the load and the center of gravity of the foundation slab, when they don't coincide, what will happen? Non-uniform settlement will happen underneath the foundation slab. So we don't need non-uniform settlement. So in order to avoid the non-uniform settlement, we always should consider the centroid point. So let it be like this only, the default option, right? So now let us model the columns, right? So the for footing one, how the column is there? So we have in this way. So make sure to click exactly at the center. If you miss out, then the problem comes. Well, while analyzing, it will show error. So currently I have made it in a wrong way. So let me go back, right. So once you see the plus symbol, just click there, right, that's it. So let us check about the remaining columns. Okay, which columns are having that particular orientation. So let me go here, right. So then the last one is also having the same orientation in the first line. So let me click here. All right. So let me click here, right. We have modeled the column and then let me check in the second line, what are there? In the second line, I guess this is the second line. Yeah. So in the second line, the center 2 we have. So let me go to here. Make sure the plus symbol should be available. Only then you click it. And then here. Okay. And then the third line, I think we don't have anything in the third line. You can see the orientations. And then in the fourth line also nothing is there. In the fifth line, you can see the center 2. Okay. Let me go to the fifth grid line. Right. So fifth grid line, the center 2. So make sure you should see the plus symbol and then click it, plus symbol and then click it. And then in the sixth line, the first one and the last one. So let me zoom it. So just click there and then the last one. Right. So that's how we can model the columns. Now, once you model the columns, see the command is still in the active. So how to make sure the command to be inactive mode? Just right click. Once you give right click, the command will go inactive. So sorry, let me come here. So once you go with this one, let me click on the select object so that the command will be disabled. So you see there is no footing or sorry, there is no column that is coming out, right? So now we have to model for the remaining ones. Okay, the remaining ones we are having square things. So let us model for the square ones. So select now what we have to do is we have to work with all the square ones. So how to model the columns? Again, just click on here. Okay, So click on draw columns in the left pane. And here we call type of object is column, property below is none, property above. Now we have to select the second one, second column. So, and then height below is 0 and height above is 2.9 meters, and plan offset, let it be 0 along X and Y axis, and the angle should be 0. When you give 0, you can see here, right? So now let us model in the remaining points. Okay, so here one thing that you have to observe is, so let me go in this way only, right? So let me give the modeling part for the remaining ones. So here, let me click here. Now you can see the shape following by the arrow is in the rectangle, but once I click here, you can see it's a square. So though the rectangle shape is coming, based upon the dimensions, whatever we have given, it will automatically consider that shape. Okay, so let me click on the next point, right? So we have modeled the two square columns, and similarly here also. So click here and then click on the last point as well. So you should follow the diagram. So I'll send you this diagram also after this session. So click here, here. You can also drag it from left to right as well. That will also work out, no problem. Right. And then the fifth line. And then these two, last one. Right. So once you are completely done with this, then just close this dialog box and then click on select object. So with this, we have modeled the columns in all the grid lines. So for each type of footing, for all the footings, we have modeled the columns. So you can check we didn't miss any of the columns here. For all the grid point intersections, we got the footings. For all the grid point intersection, we got the respective columns as well. So now if you want to see these things in the 3D model, so just click on 3D and you can see the slabs has been modeled. If you want to rotate them, so you can just rotate them. See, that's how they'll come. Okay, so I hope it is clear how to model these ones. Right. So let's go to the XY plane and let us work with the remaining parts. So now the next thing is we have modeled the columns. Now, so let me give it here. So step 4 is slab properties. Step 5 is modeling of footings. So let me write that. Modeling of footings. That is step 5. Step 6 is modeling of columns, which we have completed just now. Now the next part is we have to assign the loads. The seventh part is assigning the loads. So load assigning or assigning the loads. So let us assign the loads now. Now, if you go to the CAD drawing, let me go there. Right. So if you go to the drawing, here you can see the loads are also given. So for column 1, so load over columns. So column 1 is carrying 750 kilonewtons of load. Column 2 is carrying 1020 kilonewtons of load. So that's how we are modeling we are going to model the loads. So now let us do the assignment of loads. Right. So for that, what we have to do is let me go to the safe, and here let us go to 3D view. Okay, so here you can see for each point. Okay, let me just do one thing. Here there are two layers that are coming. Let me just show you only one layer, which is the ground layer. For that, let me just check it if I have missed out one thing. I have to show you one thing. So just give me a second. I'll check that option where exactly it is. It is not here. It is not here also. View. Just give me a second. Right. So let me do this way. So here, right. So now here I am seeing two layers. So now let's say I want to see only one layer. Okay, that is, let's say I want to see only the datum level, that is 0 level in 3D also. So how to do that is just go to edit. In the edit, we have this option called grid data. In the grid data, you can see an option called add or modify grids. Okay, add or modify grids, click on that, and then you can see this dialog box which is popping out. And here you can see an option called modify or show system. So just click on that. One more dialog box will get popped out. And here you can see story height above. Okay, here let me give all these points as 0. Model datum here, these ones, these 3. So let me give it as 0 so that I don't see the second layer. So I'll see only one layer so that in 3D view, we'll see better options. So let me give all as 0 and then click OK and click OK. Now you can see. So you don't see multiple layers. You are going to see only the first layer. Let me click on this one. Right. So let me rotate it a little. Let me do some more rotation. Right. So this is how we are going to do this. So now what we have to do is we have to assign the loads. Now in order to assign the loads, let us go with the 3D view itself. So you can assign the loads either in 3D view or in 2D view also, but it is better to assign the loads always in 2D view, not in 3D view. Right. So why I'm telling, I'll tell you. So here, if you want to select all the columns, let's say, how do you select all the columns? You're going to drag it from left to right, and then all the columns will get selected. But here, the problem is you can see at the bottom left side of the screen, 144 points, 24 lines, 24 areas, 96 edges. So that means it has selected all the columns, it has selected all the footings, and it also has selected all the areas of the footings also. But we don't need it in this way. So we want to assign the loads only for columns. Why? Because column load will be different. So whatever the load that is coming from the column, all that load will get transferred to the footings. So that means whenever you are assigning the loads, even in pictorial representation also, we always represent the loads that are coming from column like this only. We never represent the loads like this on the footing slab, right? So that's the reason why we need to give the column, we need to give the load only on the column. So let us do that. So for that, let me go to the XY plane. So let me clear this selection, clear selection, CLR, and then go to XY plane, right. So now what we have to do is we have to assign the loads. So just click on XY plane and then go to select and then select. Okay. So now we have this option called properties. In the properties, we have to select which properties we have to select column properties. Why? Because we are assigning the loads on the columns only. So select column properties and a dialog box appears. And here you can see the 2 columns that we have selected. Okay. So now let us work with the first column, that is 230 by 600 underscore M20. This is column 1 and this one is column 2. So let us work with column 1. So select column 1, okay, and then click on OK. Now you can see at the bottom, okay, can you see at the bottom? Automatically it is coming down. At the bottom, 8 lines selected. Okay, you can see at the bottom, 8 lines selected. That means all the columns automatically, which is having a category of C1, they got selected automatically. So how it got selected? Let us do one more time. So let me do the clear selection. So click on this one, clear selection. And now you see nothing is there. It is showing ready at the bottom. Can you see here? It is showing ready. Right. So now let us go with this. So how to go with that? Go to select. Okay. Select and then properties. Which properties? Column properties. Click on column properties. Select the column whichever you want. Select 230 by 600 and then click OK. Now, as soon as I click OK, just observe at the bottom right side, left side of the screen, it instead of ready, it will change to 8 lines selected. Okay, 8 lines selected. Now, what you have to do is just right click anywhere on the screen. Okay, just right click anywhere, keep the cursor somewhere in your screen, not just on the model, anywhere you can keep. So just keep the cursor anywhere on the screen and then right click, right click. So once you do right click, you can see an option called show selected objects only. Now here, what does it mean? It means it is showing that 8 lines selected. But what are those 8 lines? Can you identify from this diagram what are those 8 lines that the safe software has got selected? We don't know. We are unable to identify them. So in order to see which columns has got selected, which are these 8 lines that got selected, so what we have to do is we have to go with this option, which is called as select. Okay, which is called as select. So how to see these 8 lines selected? So for that, just right click anywhere on the anywhere in the window, just right click, and you can see an option called show selected objects on. Click on that. And can you see now what are those selected objects? You can see some one point is here, the other ones, these 2 columns, and then these 2 columns, and then these 2 columns. So if you zoom it, you will understand much better. Let me zoom that. Let me delete these ones. Right. Now, can you see? So whichever ones we have selected with column 1 property, all those ones has got selected. Okay, that's how we can see selected all. Now for these selected objects, okay, for these selected, why I am selecting only these? Because these are belonging to column 1 category. If you remember here, so all these ones belongs to column 1. All footing 1 belongs to column 1 category. So column 1 is carrying how much amount of load? 750 kilonewtons of load. So now let us assign 750 kilonewtons of load for all these columns, for whatever the 8 lines selected. For all these ones, let us assign the loads. Right. So now, one thing that we have to remember here is don't select the column points by keeping in XY plane. Okay, by keeping in XY plane. Because the reason is if you select the column points in the XY plane, okay, there will be some errors. Why it is? Because for every line, okay, if you consider this line, let me make it in a bigger way. So if you consider a column, suppose let's say, oh, it's too big. So if you consider a column, so for every column, we have 2 points. One is at the top and another is at the bottom. So when you select in XY plane, what will happen is the top point will get selected and bottom point will also get selected. So it means for each column, we have 2 points. But where the load will actually come, the load will actually come from the top point only, not from the bottom point. Bottom point, we don't get any load. Or if you assign the loads either at top point or at the bottom point. That's completely up to you. But don't assign the loads at both points. Then it becomes a problem. Okay, while doing the analysis part, it becomes a problem. So what you have to remember is for every line, we have 2 points. So you have to assign the load either at the top point or at the bottom point. That's completely up to you. There is no problem. You can apply the loads at the top point or at the bottom. But if you assign the loads both at the top and bottom points, then what will happen is, so column 1 is carrying how much amount of load? Let's say it is carrying 750 kilonewtons of load. So column 1 will carry at top point, it will carry 750 kilonewtons of load. At bottom point also, it will carry 750 kilonewtons of load. So the total will become 1500 kilonewtons. But actually, how much column 1 is carrying? It is carrying only 750. But if you model the column loads both at top and bottom point, it is going to carry twice the amount of original load. So to avoid this confusion, we always have to assign the loads. Okay, we always have to assign the loads by keeping it in the 3D view only. Because in 3D view, we'll be clearly seeing which is a top point and which is a bottom point. Here it is an XY plane, so we don't generally define which is a top point and which is a bottom point, right? So that's the reason why we need to go with 3D view while assigning the loads. Suppose let's say if you drag it from left to right. Okay, if you drag it from left to right, let me click here to get selection. Now here at the bottom right side of the screen, bottom left side of the screen. Now can you see it is ready? Now, what I'll do is I will drag it from left to right in any column. So for this column, I'm dragging from left to right. Now, how many points it should have? 2 points. Why? I was mentioning. So for each column, we have one top point and we have one bottom point. Let us understand that. So here, just drag it from left to right. Now, observe in the ready on the, bottom left side of the screen. Once I select this one, now can you see how many points are selected? 2 points. But can you see those 2 points here? No. We are literally seeing only 1 point, but we don't know whether it is the top point or bottom point. So it is clearly telling that you have selected 2 points. How many lines we have selected? 1 line. What is that line? It means line is a column. Okay, line is a column. So that's the reason why you should not select that. So how to go to the previous selection? Just click here, just clear it. So you can see again ready. So that's the reason why you always assign the loads in the by keeping yourself in the 3D view. Okay, by keeping yourself in the 3D view. Right. So now let us go to 3D view. So just click on 3D, right. So now here you can clearly see, just let me rotate it into the convenient way. Right. I hope now you can see. So for each point, right, can you see the columns? So the vertical ones that are there. So you can see the lines, the vertical lines are the columns. Now for each line, can you see the points? So with blue color press symbol, if I leave the cursor, it will go. So that's why I'm holding the cursor. Right. Can you see the points? So there are 2 points are there. So now, as I was mentioning, you can assign the load either on the top point or at the bottom point. That's completely up to you. So just click on 3D view. Okay, click on 3D. See, all these vertical lines are columns only. So don't think they are outside of the grid lines. They are actually inside the grid line. Since I kept in different view, it is showing like that. But once I rotate this one, I'll see exactly on the grid points it is there. So no problem with that. So don't think you have modeled somewhere outside of the grid lines. They are actually modeled inside the grid lines only. See, just click on the scroller button. You will see that. If you leave the scroller, it will be visible as outside of the grid point intersections. Right. So now what we have to do is select the top points. Let us assign the loads at the top points. Okay, select the top points. So you can see point here. Let me click here. Right. So let us select the top point. So click on the top point. You can see point here. So click on the top points only. Either you can assign at the bottom points also. Again, that is completely up to you. In either ways, it will go correct only. But only thing is you should not assign for both the points. That you have to remember. So select the top points for all column ones. So I'll select this point. Okay, you can see at the bottom, can you see? Bottom left side of the screen. How many points selected? 1 point. Similarly for the remaining ones also. So let me select for this one as well. Right. So this one, right. So 2 points selected, you can see there. And then for this one, 3 points selected. For this one, you can see, yeah, this is the point. Let me just check that. Let me just have a cross check where it is exactly there. It is actually coinciding with the line. So I'll just rotate. Before rotating, I'll just select the remaining points. So 4th point, and then 5th point, 6th point, 7th point. So 7 points we have selected. We are left with this one. So let me rotate in a convenient way so that I can see that clearly. Right. So click on this one. So 8 points selected. You can see. So 8 lines we have. So 8 points we have selected. Now what we have to do, we have to assign the loads for all these points. So how to assign the loads? Just go to assign load data. Okay, assign load data. Which type of loads? They are all point loads. So just click on point loads. A dialog box appears. Right. So here you can give the name. So logically speaking, they're all what are these loads? That 750 kilonewtons of load. That's a dead load or live load. It's basically a live load. So let me give it as name as live. Okay, let's give the name as live, and then the x, I mean loads along x, y, and then gravity, that is minus z, moment along x, moment along y, moment along z, and then size of load for punching shear. We'll talk about that. So let's come one by one. So do we have the load along x axis? No, we will never have. Will we have the load along y axis? No, we don't have. The gravity, that is z axis, we have the load. Gravity loads are nothing but which will be acting from top to bottom. So this is basically the z axis. So here you can see x and y are represented in terms of positive and z is represented in terms of negative. That means positive means loads are applying from bottom to top. This is positive load. When the load is coming from top to bottom, that is basically a negative load. So all the gravitational loads are negative loads only. Okay, gravitational force is a negative force. So let me give the value here for z. X and y are always 0 because we don't have the loads at the bottom. Now you may tell that how about the soil safe bearing capacity of the soil? The upward soil pressure will be there. We'll talk about that in some time. So let me go with the z load, which is the gravitational load. What is the load value? 750 kilonewtons for column 1. Moments we don't need to give, it will automatically calculate. We don't need to give any external moments. If there are any external moments, we can give, but usually we will get the moments once we do the analysis part, right? Now the next thing is size of load for punching shear. Okay, this one, size of load for punching shear. So what is the size of load for punching shear? That means here we have to give the column size. So what is the column size? Column 1 size. Column 1 is having a size of 230 mm by 600 mm. Okay, 230 mm by 600 mm. So whichever is the smaller dimension, that will become X. Whichever is the larger dimension, that will become Y. Remember this. Okay, whichever is the smaller dimension, that will become X. Whichever is the larger dimension, that will become Y. So let me give the values. So the value of X in terms of mm is 230, and the value of Y in terms of mm is 600 mm. That's the column 1 size. So it's basically size of load for punching shear is, it's basically the size of that particular column, right? So here, based on column size, software will consider area of punching shear. So once we do the analysis, we'll get to know that. But we know that punching shear is nothing but two-way shear. Okay, remember that we have two types of shear: one-way shear and two-way shear. Two-way shear is also called as punching shear. Okay, two-way shear is also called as punching shear. So one-way shear will act at a distance d from face of the column. Two-way shear will act at a distance d from d by 2 at a distance d, d by 2 distance from face of the column. This I hope you remember. We discussed these ones clearly in the manual design part, right? So here I have given the x dimension as 230 and y dimension as 600 mm. Now the other part which is important is this one: add to existing loads. The first one, replace existing loads, delete existing loads. What does this mean? The first one is add to existing loads. It indicates if there are any existing loads. Okay, suppose let's say here we are designing only the foundations, but when you go to the ETAP software, you will design the load, you will have the loads for slabs, you will have the loads for beams, you will have the loads for columns. So now when you are assigning the loads for columns, you have to consider the load of slab and load of beam as well. So let's say the slab load is having 10 kilonewtons, beam load is also having 10 kilonewtons, column load is carrying some, let's say 20 kilonewtons. Okay. Now for you should not directly give the column load 20 kilonewtons only. You should add to the previous loads. That means here the column load should be, the original column load is 20 kilonewtons, slab load is 10, beam load is 10. So therefore total 40 kilonewtons you have to give. If you give 20 kilonewtons directly, then you can select add to existing loads. If there are any existing loads, this value will be added to the previous loads. That is what it means. And the next option is replace existing loads. If there are any previous loads that are there, it will replace all the previous loads and it will consider only the existing loads, whichever load that you give. And the next one is delete existing loads. If there are any existing loads, it will delete all the existing loads. That is what these 3 points. So usually what we select is, since we don't have any type of loads here, either you can go with add to existing loads or replace existing loads, right? You should not go with delete existing loads. If you select delete existing loads, you can see, observe here. So no load is being applied here in the Z direction, especially. So we always either have to consider add to existing loads or replace existing loads. If you confuse, just directly go with replace existing loads. Then there won't be any problem. Okay, right. So let me give the value here. The Z value is 750. That's the load, and the dimension is it is 230 by 600. 30 by 600, and then click OK. Once you click OK, what will happen is the load will appear. Now here, before I click OK, can you see any loads on the points here? No, there are no loads that are being shown. Now, once I click OK, what will happen is you will see the loads, the downward arrow you will see. So I'm just clicking OK. Now, can you see the loads are coming down? See, 750, 750, 750. So all these columns are having a loads of 750 kilonewtons. So that's how you can work with the application of loads. So let me go to the XY plane. Let us see. See. So each XY plane is having a load. The red color one indicates the load only. If I zoom it much here, you can see. So the red color one that you see, right? It's a load, the circular one. Okay, right. So let us assign the loads for the remaining columns also. Okay, so this is how we can assign the loads for column 1. So we have to assign the loads for column 2 also. Okay, we have to assign the loads for column 2 also. Now we can also apply load, as I was mentioning, at bottom of column also, but don't apply the load both at top and bottom. But another thing that you have to remember is for column 1, where we have applied the load at the top. But for column 2, don't apply at the bottom. So maintain the uniformity. For column 2 also, you apply the loads at the top only. Okay, so that while doing the analysis, there won't be any errors. So either you apply both at top or at bottom or any one. That's completely up to you. But don't apply top and bottom. That you remember, right? So let us apply for the column 2. So just go to XY plane. Okay, let me click right click and then click on show all objects. Now I want other columns also. Okay, so let me click on these ones. Let me show selected object. Yeah, show all objects. You can see here. Click on them. So you can see all the objects are coming down. Now we have to apply for the remaining ones. Now we have to apply the loads on column 2 also. So let me go to the section. What is the load on column 2? 1020 kilonewtons. So let me apply the loads first. So go to select, okay, select and then properties. In the properties, we have to apply the loads, right? So just click on select properties, and then which properties we have to apply? Column property loads. So click on column properties, a dialog box appears. Select the second column, that is C450 by 450 underscore M20, and then click OK. Now can you see at the bottom 16 lines selected? Okay, 16 lines selected. So now if you do right click and then show selected objects only, you can see the remaining ones, the square columns and square footings, right? So now you can see 16 lines selected at the bottom. Now it is not there, but it's gone, right? So now we have to assign the loads. Okay, how to assign the loads? Just go to assign. Okay, go to assign and then load it. Why it is coming like this? So all objects, let me give here. Let me click here. Let me clear my selection. Right. So show selected objects, sorry, show all objects. Let me go again. So select properties, column properties, and then select column 2, click that, and then show selected objects only, right? Okay, then. So now let us apply the loads. So assign, why load data is not coming down? So let me just have a cross check, because in 3D, for which columns I have assigned the loads. Let me rotate it. Just give me a second. Have I applied the loads in a different way? Let me select properties, column properties. Let me select column 1. Okay. View. Okay, I think I have applied the loads correctly for all these columns only. Right. Let me, why the load display items is not coming? Go to XY plane. Okay, now I have to apply for these ones and then assign. So here load data is the, just give me a second, I'll just check that. So here it should not be 8 lines selected, it should be 16 lines selected. Let me go to select, and then properties, column 2, click on this one. So it is showing 24 lines selected. So it actually should have 16 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But why it is showing 24? Let me go to 3D view. So there is some error that is coming down here. Let me have a cross check. Let me go with the first column. Then, okay, this is 8 lines selected. That is fine. Then select properties, column properties, this one, and 24 lines. Here it is showing 24 lines, but technically speaking, it has selected only 16 lines only. Why it is showing? Okay, let me do one thing. Done. So there is some error. I'll just check with this one. Anyways, we'll do this one. We'll continue this one in the next session. So here there is some mistake that might have happened. So I'll just cross check that mistake, what actually happened, and then I'll discuss that in the next session. Right. That's from my end. In the next, I mean, if you have any doubts, you can unmute and ask the doubt. This one, even like here it is correct only, but we are selecting the right options only. Column properties. Let me select column 2. Right, and now it's coming. So 16 points is selected. Now let me go to assign. Let me just do this. Right, assign load data. It is not popping out. What could be the error? Right. Anyways, I'll check with these ones and I'll discuss this one in the next session. Right.
Okay, sir. Thank you.
Yeah. Thank you, sir.
I think it seems like Strat Pro mostly.
Yeah, it's something like that only, sir. Yeah.
Yes. Yeah. Okay, sir. Thank you.
Yeah. See you, sir. Thank you.